How rocket works, the science behind space exploration. Have you ever wondered how rockets work? In this article, we will dive into the fascinating world of rocket science and explore the mechanics behind space exploration. From the ignition of the engines to the journey beyond Earth's atmosphere, let's unravel the mystery of how rockets propel themselves into the vastness of space. Igniting the engines, the power of combustion. Rockets rely on a powerful force known as combustion to generate the thrust needed for liftoff. Combustion is the rapid chemical reaction between a fuel and an oxidizer, resulting in the release of energy in the form of hot gases. In a rocket engine, this process occurs within a combustion chamber where fuel and oxidizer are mixed and ignited. Thrust generation, Newton's third law. Newton's third law of motion comes into play once the rocket engines are ignited. This law states that for every action, there is an equal and opposite reaction. When the hot gases produced by combustion are expelled through the rocket's nozzle at high speeds, they create a force in the opposite direction. This force, known as thrust, propels the rocket forward, overcoming the force of gravity. Stages of a rocket, reaching escape velocity. Rockets are typically designed with multiple stages to reach the required velocity for space travel. Each stage contains its own engines and propellant. The first stage, often the largest, provides the initial thrust needed to overcome the Earth's gravitational pull. Once its fuel is depleted, it is jettisoned, and the next stage takes over. This process continues until the final stage, which propels the spacecraft to its desired orbit or beyond, known as escape velocity. Orbital mechanics, achieving stable trajectories. Once a rocket reaches space, it must achieve a stable trajectory to ensure a successful mission. This is achieved through a combination of velocity and precise orbital calculations. By firing the engines at specific times and angles, the rocket can enter into an orbit around a celestial body or travel to distant destinations within our solar system. Re-entry and landing, making a safe return. After completing its mission, a space vehicle must return to Earth safely. Re-entry involves withstanding extreme atmospheric conditions, including intense heat caused by air friction. The spacecraft is designed with heat-resistant materials to protect it during this phase. Once through the atmosphere, the rocket can deploy parachutes or use controlled propulsion to slow down and safely land on solid ground or in water. Conclusion. Understanding how rockets work is key to comprehending the incredible achievements of space exploration. From the ignition of engines to the complex physics behind stable orbits and safe landings, each step in a rocket's journey relies on precise engineering and scientific principles. Rockets continue to serve as the gateway to the mysteries of space, allowing us to explore and expand our knowledge of the universe.